What are significant figures? The term significant figures refers to the number of important single digits from 0 to 9 present in an expression indicating the accuracy of a measurement. In a measured quantity, significant figures are the digits which are absolutely correct plus the first uncertain digit. For example, if we measure the length of a glass plate using a scale, depending on the instrument used to measure, let's suppose this length lies somewhere between 2.6 cm and 2.7 cm, and we finally conclude the length as 2.63 cm approximately. In this measurement, the digits 2 and 6 are reliable, but the digit 3 is uncertain and represents an approximation. Therefore, the combination of all the reliable digits and the first uncertain digit is known as significant figures. Let's understand the rules for counting significant figures. Rule number 1. All non-zero digits are significant. For example, the number 126.28 has 5 significant figures. Rule number 2. The zeros appearing between two non-zero digits are significant. For example, the number 6.025 has 4 significant figures. Rule number 3. Trailing zeros after decimal places are significant. For example, the number 6.400 has 4 significant figures. Rule number 4. The power of 10 are not counted as significant figures. For example, 1.4 into 10 raised to power minus 7 has only 2 significant figures, 1 and 4. Rule number 5. If a measurement is less than 1, then all zeros occurring to the left of the last non-zero digit are not significant. For example, the number 0.0042 has 2 significant figures, 4 and 2, because we can write this as 4.2 into 10 raised to the power minus 3. Rule number 6. Change in measurement of a quantity doesn't change the number of significant figures. Suppose a measurement was done using millimeter scale and we get length equal to 72 millimeter. Then it has 2 significant figures. If we measure same length in centimeter, meter and kilometer, then in all 3 cases, it will have 2 significant figures. Rule number 7. The trailing zeros in a number without a decimal point are not significant. For example, 2,35,000 has 3 significant figures, as this can also be written as 2.35 into 10 raised to power 5. Rule number 8. Exact measurements have infinite number of significant figures. For example, 10 bananas in a basket, 46 students in a class. Speed of light in vacuum is 299,792,458 meter per second exact. The value of pi equal to 22/7 exact. All these measurements have infinite number of significant figures. Let's solve an example based on this concept. Question. The respective number of significant figures for the numbers 23.023, 0.0003 and 2.1 into 10 raised to the power minus 3. The options are. This question was asked in JEE Main 2010 exam. Solution. Let's use the rules we have just learned and apply them to each of the given numbers. Number of significant figures in 23.023 is 5 because the zeros appearing between two non-zero digits are counted as significant. Number of significant figures in 0.0003 is 1 because all trailing zeros without a decimal point are not significant. Number of significant figures in 2.1 into 10 raised to the power minus 7 is 2 because the power of 10 are not counted as significant figures. Hence, option A is correct. Moving on to the next example on significant figures. Question. A student performs a titration with different burettes and finds the titrate values of 25.2 ml, 25.25 ml and 25.0 ml. The number of significant figures in the average titrate value is. This question was asked in JEE Main 2010 exam. Solution. we are given three titrate values: 25.2 ml, 25.25 ml and 25.0 ml. The number of significant figures in each of these measurements are 3, 4 and 3 respectively. The average titrate value is 25.2 plus 25.25 plus 25.0 whole divided by 3, which is equal to 25.15. Since the lowest number of significant figures among the measured values is 3, therefore, the number of significant figures in the average value will also be equal to 3. Hence, we will round off the average titrate value to 25.2 ml. Watch our video on rounding off numbers to learn more about it.
Please like, share and comment on the video, and don't forget to subscribe to our YouTube channel. For more interesting and educational videos to earn while you learn, download Extraclass app from Google Play Store and get rewarded for studying.